Hello, welcome to T-Level Tactics and this video on design tools for Root Core 4 Digital Analysis and the T-Level Digital Support Services course. And in this video, we'll identify some design tools that could be used with computational thinking. We'll explain the purpose and benefits of these design tools, and we'll also use them to help build a solution. Before we get started, these videos are not endorsed or sponsored by any education institution or qualification awarding body. And T-Level Tactics videos should not be used as a replacement to any classroom learning you might be receiving, as the discussion and practical activities with your peers and lecturer will help to expand your thinking and comprehension. Instead, these materials are best used as preparation material or as revision to reinforce your learning. These videos also cover the same content and required knowledge for Root Core 4 of the T-Level Digital Business Services course. However, they will be more contextualized towards IT support roles. So what design tools are there? While the key stages of computational thinking can help us break down problems, there are some additional tools we can use to help us explore solutions more thoroughly, and can help us to visualize and structure solutions as well. There are three that we'll take a look at: decomposition diagrams, flowcharts, and pseudocode. And it often works best if you create them in that order. Let's take a look. Decomposition diagrams are visual tools used to break down complex problems into smaller, manageable components. They represent the hierarchical structure of a problem or project. A decomposition diagram displays a project and its components in a top-down hierarchical format, and each component can then be further subdivided into subcomponents or tasks. And decomposition diagrams provide a clear overview of the entire problem or project, making it easier to understand. In the last video, we used decomposition to help design a personal budgeting app. There were 5 main features we identified: user registration and login, income tracking, expense tracking, budget creation and management, and reporting and analytics. And we can map these out in a decomposition diagram for easy reference. Here's an example of what that might look like. And under each key feature, we can then add in additional detail for functions we want, like login, registration, forecasting, and visualizations. The benefits of decomposition diagrams are, well, they simplify complexity, making it easier to tackle large problems by focusing on smaller parts. They can enhance collaboration, clarifying roles and responsibilities among team members. And they can help in identifying necessary resources and timelines for each component. And it can encourage systematic thinking and organization of problems. Flowcharts are diagrams that visually represent a process or algorithm using standardized symbols and arrows. They illustrate the flow of control and the sequence of steps in a process. Flowcharts use a standard set of symbols to represent different parts of a process. Ovals represent the start and end points of processes. Rectangles indicate a specific process or action step. Diamonds represent a decision point where a choice must be made. And arrows show the direction of flow from one step to another. Once you've created a decomposition diagram, you can then use flowcharts to help map out how each function or element works, and break it down to its basic elements. Think of how the data or user will then progress through each process. Flowcharts provide clear and intuitive representations of processes, making them much easier to understand. They facilitate discussion and collaboration among team members, providing a common visual reference. They can also help in spotting inefficiencies, bottlenecks, or potential issues in a process. And they're also useful to trace the flow of logic, helping to debug any issues that come up and identifying errors in the algorithm. Once you've got your flowcharts ready, you can then start working on some pseudocode. Now, we've briefly looked at pseudocode before. In video 1, Algorithms, we looked at how algorithms can be expressed in structured English. And structured English is a type of pseudocode. Pseudocode uses the structure of programming languages, but is written in plain language. It focuses on the logic of the algorithm rather than specific programming syntax. And it can be used to create high-level descriptions of algorithms. Pseudocode is easy to read and understand for people. It's not tied to any specific programming language, making it much more versatile and readable. But it does clearly outline the steps and logic of the algorithm, so you can quickly change and modify before you get to the coding stage. Knowing what to write pseudocode for becomes easier once you have your decomposition diagram and flowcharts completed. It's almost like taking your flowchart and making it understandable for a computer, but without doing any real programming yet. It's a good idea to write some pseudocode for each function to indicate what it will do and how it will work. Here are some simple tips. Identify your inputs and outputs. Break the problem down into smaller steps or tasks, and then arrange the steps in a logical order. Make sure you use plain English that can be understood by anyone, and use indentation in your text editor for clarity and readability. You can use keywords like function, return, if, else, for, and while to indicate actions. And make sure you incorporate common programming constructs like loops and conditionals to represent logic. And then test your logic and revise your pseudocode as needed. Remember, you can do it as many times as you want or you need. Let's say we wanted a function that adds all the numbers in a list together. We know that we start with a list of numbers, that's our input, and that we want the sum of those numbers at the end as our output. Our pseudocode could look a little bit like this. We could have a function, call it calculateSum, and then we know that our input is going to be some numbers. We can set a variable called total to 0, and then use a for loop, so that each number that we've entered, we add to our total. Once we've done that for every number in our input, we can end the for loop and return the total of that variable once it's been added together. And we can end our function at the end. So, we've used the function keyword at the top. We've created a total variable, set it to 0. We've used a for loop that loops for as many times as there are numbers. Closed the for loop at the end. Returned an output. And we've got a clear end to the function as well. Pseudocode helps in planning algorithms without worrying about syntax, and it promotes a focus on problem solving and logic. It can also serve as a bridge between human language and programming languages, make it easy to share and discuss with team members or stakeholders. So if you're a Patreon member, you can head to patreon.com/tleveltactics and download the task sheet for this video. And you can have a go at the first task. If you're not a member yet, head over to patreon.com/tleveltactics and get signed up as a T-level tactician to get access to all the exclusive resources our members receive, including task sheets, workshops, and our podcast editions as well. Once you've got the task sheet, spend about 30 minutes on this task. Pause the video while you have a go, and then come back when you're ready to move on. Let's have a go at using some of these tools. Design tools are essential for software development, but they can also be put to good use in other areas as well, such as project management. Let's put these tools and our knowledge of computational thinking to some use. Here's our scenario. You're part of a team tasked with designing a mobile application called Study Buddy. The app aims to help students connect with peers for study sessions, share resources, and track their study progress. Your goal is to create a user-friendly app that enhances collaborative learning. Our app will have 4 main elements. User management, where users can register, create a profile, and log in and out. Study sessions, where users can create a study session, join a study session, and schedule sessions. Resource sharing, where they can upload resources, share links, and make comments. And progress tracking, where they can set study goals, track their study hours, and view progress reports. You're going to need to do the following. Create a decomposition diagram of the application. Create a flowchart that maps out the user journey through the app, and for an example process such as creating a study session. And write some pseudocode for a specific feature of the app. Now, if you're watching on YouTube, make sure you flick back to earlier in the video to see a recap of how those design tools work. But for our Patreon members, you can follow the additional guidance on the task sheet. I recommend you spend about 50 minutes using those design tools to come up with a solution for that scenario. Pause the video here, have a go, and then come back when you're ready to finish off with some exam-style questions. So, in this video, we've identified some design tools that could be used with computational thinking. We've explained the purpose and benefits of different design tools. We've also used those design tools to have a go at building a solution. Here are some exam-style questions to finish off. Describe what a decomposition diagram is and explain its purpose in problem solving. And create a simple flowchart to illustrate the process of making a cup of tea, using at least 3 different symbols. And that brings us to the end of the video. If you're watching on YouTube, this is the final video in Root Core 4 Digital Analysis. But for our Patreon members, there is one more video in the form of a Patreon exclusive project that will put all of your skills and knowledge to the test. If you're watching on YouTube, then keep an eye on youtube.com/@TLevelTactics for Root Core 5 digital environments that will be coming soon. And if you're not a member of our Patreon yet, head over to patreon.com/TLevelTactics to get access to that Patreon exclusive project coming up and all of the other resources that our T-Level Tacticians get access to, including the workshop videos, task sheets, and our exclusive podcast editions as well. Thanks for watching, and see you in Root Core 5 digital environments, or in the Patreon exclusive project if you're a member. Bye for now.